In this lecture, we will learn about using the NumPy and SciPy libraries for image manipulation. The first example we will look at will use NumPy to read an image to an array, and then lighten each pixel by half its color. Up at the top of the program, we will import matplotlib.pyplot as PLT, we will import NumPy as NP, and we will type from pil import image to import the image class from pillow. Then we will create a variable named img, which will be responsible for storing our image. We will set it equal to image.open and pass in the string sampleimage.png, the image we have been using as an example in this section of the course. After that, we need to use NumPy to convert the image into one big array of pixel values. To do this, we will type arr and set it equal to np.array and pass in image. Then we will set r equal to r divided by 2. Next, we will use matplotlib to save the image to a new file. We will type plt.imsave and pass in lighterImage.png as the first argument, and r.astype npuint8. When we run the code, notice that there is now a file in the same directory as our Python file named lighterImage.png, and that each of its pixels was reduced by half the color. That is a look at how NumPy can be used to manipulate an image by converting it to an array of pixels, manipulating them, and then saving them back into an image. Now let's learn how to use SciPy for image manipulation. Up at the top of the program, we will import ndimage and misc from SciPy. We will also import matplotlib.pyplot as plt. Then we will create a variable named fig and set it equal to plt.figure. After that, we will create a variable named ax1 and set it equal to fig.addSubplot and pass in 121. Next, we will create an ax2 variable and set it equal to fig.addSubplot with 122 passed in. Then we will create a variable named img and set it equal to misc.ascent. This image is an image stored in SciPy's misc library and is a picture of someone walking up a flight of stairs. After that, we will create a variable named result and set it equal to ndimage.zoom and pass in img as the first argument and 3.0 as the second argument. Next, we will type ax1.imshow and pass in img as the first argument, vmin equals 0 as the second argument, and vmax equals 255 as the third argument. Then we will type ax2.imshow and pass in result, vmin equals 0, and vmax equals 255. Finally, we will call plt.show. When we run the code, you will notice that a SciPy figure is showing two images side by side. Let's break down exactly what is going on here. On the left is our original image. It has a width and height of 500. We specified a zoom of 3 on this image, so to the right is the image at 1500, 1500. Do you know those TV shows like CSI where they zoom in on an image of the suspect? Check this out. Click the magnifying glass icon, and then click and drag a rectangle around the man on the image to the right. Notice that he was zoomed in on. Want a better look at the backpack? Click and drag around just the backpack. This is a real-life example of how Python can be used to analyze an image for details, and personally I find that unbelievably cool. In the next lecture, we will learn how to create a Sobel filter using Python code.